in today's video, we're gonna go over Newton's laws of motion, and this should help you with high school physics or AP physics. Maybe maybe. And physics was my favorite class in high school. Not because I was good at it, because I don't know, it was interesting. So let's. I'm tired. I'm low-key gonna take a nap, but I'll do it after. Okay, so first off, this is. Oh, I remember I was really bad at loss of motion. It's fine though. Okay, first off is the law of inertia, and an object will remain in motion unless it's acted upon. And the forces that contribute to equilibrium is called the F of net. And static equilibrium means the object is at rest. So V is velocity. Velocity is not like speed. Speed is a scalar. That means there's only uh there's no direction to it. But velocity has direction tied to it. So right here you have a mass, right? And there's the applied force, which is pulling it that way, 10 newtons, right? But there's another force pulling on it that way. So the F of net, or the net force, is zero, so it won't move anywhere. And that's static equilibrium. But dynamic equilibrium is when objects are moving at a constant rate. So that means it's not accelerating. Acceleration means changing velocity, but if it's constant, there's zero acceleration. Let's see. Okay, the second law is F is equal to ma. So this is basically acceleration, and acceleration is directly proportionate to that force, and it's inversely proportional to mass. So if you rewrite this equation, you get F is equal to F net over m, and that equals F is equal to ma. And see, we have two vectors, the x and the y vector. And to get this vector, if you have force, you can do this times the sine. So sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. That's really important for physics, so make sure you know your sine and cosine. Sorry, I'm tired. Okay. And okay, in physics, you're gonna need to know free body diagrams, and that just like represents all the forces acting upon a single body. So the normal force always is perpendicular to the ground, I think, to the plane, and then force of gravity is always pointing downwards no matter what, pointing this way down. And this tension and friction, and yeah. So the common forces we have is gravity, straight down, yeah. Like I said, normal force is perpendicular to the surface. Tension, like ropes, strings, cables, and friction, like when you rub something against a surface, there's gonna be friction, and friction can turn into heat, but it's also a force pulling the opposite way to like tension in a way. Okay, so static and kinetic friction. Static friction is when an object is stationary, and that means there's the most, because when something's at rest, it's harder to start it like moving in a way, because it's stationary, so you gotta get it moving. But if it's kinetic, it's already moving, so it's less. That's why there's force of friction is equal to the coefficient of friction times F at the normal force. Yeah, right here. And kinetic friction acts when sliding. Yeah. And here's applied force. You can look at this. Okay, inclined plane. So when this is also very important, you have like a box on top of a triangle, and the normal force is that way. The force of gravity is pulling it downwards. But force of gravity, there's also F of gx, F of gy, and that's how you find the force pulling that way and the force pulling that way. If there is a force pulling that way, but the question will tell you that. And since there's no motion perpendicular to the ramp, you have this equation. Oh yeah, the equation is F of the force of gravity is equal to m times g times sine or cosine. Okay, the third law. The third law is uh action reaction pair. So if you push on an object, it will have an equal and an opposite reaction to it. So a common misconception is that if forces are equal and opposite, shouldn't they always cancel out? And that's actually not true because action reactions forces act on different bodies, so they never appear on the uh same FBD. I'm not sure what that stands for. I guess it's just same plane, I guess. Not sure. Let's keep going. Okay, so here's a practice problem. Uh, a 5 kilogram box is pulled along a flat floor by a horizontal force of F equals 25 newtons. N is newtons, by the way. The coefficient of kinetic friction between the box is 30, and assumed gravity is 9.8 m over s squared. So I want you to solve for the normal force, the kinetic friction force, and acceleration of the box. Make sure you draw the free body diagram. So make sure you draw it out. Always draw it out. Always draw it out. Don't be like me who never draw it out. And I'll go over the answers soon. I'll give you this will take a couple minutes. So just pause it or just I don't know. Okay, so let's hope this slide has the answers. Okay, so here are the solutions. So for the first one, you wanted to use f of n is equal to mg, and and then you do 5 kilo. Make sure you put your units, by the way, too. Put your units. I got points taken off because I didn't use my units. So you should have got 49 newtons, 14.7 newtons, and the last one was kind of tricky. The applied force minus the kinetic friction is equal to m times a. And you should have got 2.6 times m over s squared. Okay, so let's keep going. Oh, we have a pulleys question. So two masses, m1 and m2 are 3 kilograms, are connected over a frictionless massless pulley. The magnitude of system acceleration when released from rest. Find it. Yeah, so this is an Atwood machine, and uh, I, I think just use what you know and the equations I gave you, and just know that okay, there's a hint that mass of 2 accelerates down and the mass of 1 accelerates upward. So I'll give you a couple seconds to solve this. Just write it. All right, that's good enough. Okay, so you should have used f of net is equal to mg m times g minus m times 1g, which is also equal to m mass of 1 plus mass of 2 and times acceleration. And substitute everything. So you can have this. I'm not sure if I gave you this equation, but if you have your chemistry, if you have a reference table, I think you should be able to like work your way through it, I guess. I can go more in depth about Atwood machines because there's a lot of units in physics. And right now I'm just going over like Newton's laws. But if you got 1.96 times m over s squared, I probably wouldn't have gotten that. So good job, good job. Okay, so summaries. F of net is when it's zero means constant velocity, not zero velocity. So that means it's still moving, but yeah. Always break forces into x and y components like f of gx, f of gy, always all that. And then on inclines, the force of the normal force is mg cosine, and downhill force is mg sine theta. That's a theta, by the way. And this depends on the normal force, not. I feel like some people might say the net force, but it's actually the normal force. And on free body diagrams, never draw the component FGX and FGY on your finite diagram because I don't know, I'm not sure why. Well, I, I think just keep it simple, honestly. You just gotta keep it simple. And then action reaction, always clearly state which object exerts a force on which object. Just be very clear and make sure to label everything. And I hope you learned something and got a basic idea of when you go into class, you have a basic background, so you do good. Okay, so I hope you have a good day. Thanks.